I am live. I don't look live. I don't see myself in the big video yet, but I am hearing that I am live, so I am going to start talking like I usually do. Welcome to Supercharged Math with Doug. We are going to be doing some algebra today. No one should be surprised by that. I have Mocha here. We're going to look at her for a second. As usual, I start off the class by talking about whatnot because some of the students may not have arrived yet. Do not hesitate to use the chat to send me messages if you want to just enter answers that you're getting, and I get to see if the students are getting the answers. Or if you want to suggest a question, that's always a possibility. I will check the chat every now and then. I really prefer if I can see myself big in the big, I don't know what to call it, the big video. But so far I can't, and I cannot spotlight myself for everyone. Speaker mode, and I'm trying to click on speaker mode. I do not know where speaker mode is. I think I might know that. Hang on. Speaker, I'm already on speaker mode. That's weird. I can go full screen, but that's still the video I'm in is still really small, and the other one is full screen. So I want to go back actually. But I will be able to teach my algebra lesson even if my video is really small. I just might have to get really close to the camera to peer at myself every now and then just to make sure things are fitting in the video. That's fine. So what's going on? It's still October. The weather is still It's that type of weather you get in October, so nothing interesting to discuss. Maybe when we start getting some snow around here, it'll be interesting, and I might even turn the camera and show a deep snow, because I know some of the students don't see deep snow. What's going on with Mocha? Well, I'm going to put Mocha on the camera right now with me. Oh, she was all comfortable. Now I disturbed her rest. She wasn't asleep. Okay, so Mocha really surprised me. Just this week, she really surprised me because I'm always making little jokes about how she doesn't understand this type of math, or she doesn't understand that type of math. But the thing is, I suspect she actually understands math pretty well, and she just doesn't know how to say so. But the other day, I looked in her crate. Now, Mocha still sleeps in her crate, which we just leave the door open all the time. She just goes in there sometimes because I guess she feels secure. And I saw this book. There's this book in her crate, and look what the book is. Interesting. So I think we have a beautiful assistant who doesn't want to be the assistant anymore. She wants to be the one who does the teaching. Well, eventually, maybe she's going to have to finish the book first. And one of these days, I'm going to borrow that book from her because maybe I'll learn something from it as well. Okay, I am going to release Mocha, so I will walk off camera just for a second. We already have a little bit of stuff here for the students to look at, and now I can see myself in the big video. That's what I want. I'm happy. So I'll be gone just for a second so I can release her because it's supper time and her supper is upstairs. Go, Mocha. Be free, Mocha. Be free. She is free. I have released the dog. I have released the hound. Okay. So, yes, the video looks good. The focus seems to be good. The focus has been behaving very well lately. Because I needed to go to the door with Mocha, I didn't have my microphone on. It's on. It's turned on, but it wasn't on me. So I'm going to pin that on myself right now, just before I start with the actual math. And while I'm doing that, I will point out to you that this jersey is Sunderland. Sunderland is a team from the Newcastle area of England, which means northeast coastal England. And they're in the Premier League sometimes. And I just like the shirt. That's kind of a cool shirt. Okay, enough about the shirt, enough about the dog, enough about the weather, and not enough about the math. We are doing algebra, and the students are here. I have to turn on the chat so I can see if the students send any messages. I want to get out of full screen mode. Don't know how to get out of full screen mode. Exit full screen, that's how. Okay, and Doug figures it out. That's good. Okay, now I can see the chat. I'm ready for everything. We are reviewing some of the stuff that we did last time. We did quite a lot of stuff involving the absolute value last time. And we'll start with a little review of some of the more basic things about absolute value. So, of course, the absolute value, that's this thing. We see these bars, the absolute value bars are a special shape that you don't really see used for anything else in math, which is good because that way you're able to recognize that when you see these straight up and down bars that are not curvy or wiggly, that's an absolute value. An absolute value means that whatever's inside the bars has to be positive, has to be made positive. So the absolute value of -10 is equal to +10. And the absolute value of +10 is also equal to +10. So no, the positive ones don't turn negative. It doesn't flip on or off the negativity. It just wants it to always be positive. Now, to review, we did some simple absolute value expressions like this one last week, but I'm going to review, and I'll start with this one. How do we deal with this? We know that if x is positive, it has to be equal to 1. So therefore, x would have to be equal to +1. But if x is negative, its absolute value would have to be equal to 1, which means if it was negative, it would be positive. That means x can be equal to -1. These are the only answers that work with this thing. If you plug either of these numbers into the x position and then apply the absolute value, they both give you +1. And they're the only numbers that are going to give you +1 when you do that. So now I can graph this on the number line. Notice it's not an inequality, so I'm not going to be doing shading. I just need dots. And I need to show 1 and -1. So I will put those on my labeling of my number line. And I'm going to put dots on both of them. And both dots have to be filled in because it's equals. So we're not using these open circle type of things, not in this case. So that's a pretty basic one. Yes, it is. But we have to do a little review to remember what it is we were doing last time so that it puts into context what we're doing this time. Now let's move on to doing a few of the inequalities that we were doing last week, very similar to the ones we were doing last week. So I'll erase this stuff and I'll put up an example. And as we're at the beginning of the class, I want to remember to give a special public service announcement, which is that Leah's study hall this week is 1 hour earlier than usual. So I just wanted to make sure that I remember to say that. Now, my example is going to be absolute value of x is greater than 3. Now, the way I was doing this last week, I was showing what is an answer and what isn't an answer with plugging. And I'm not going to do that very much this week, but I am going to do it with this example because, again, this is sort of a review. This is a remember last week part of the class. So we'll try plugging different values into this and seeing what happens. If we put in a number like 2, the absolute value of 2 is +2, and +2 is not greater than 3. That's a no, that doesn't work, but that makes sense. The absolute value of 2 is not greater than 3, so that means 2 isn't going to be part of our answer. I need a number line so I can start seeing what I'm going to do with that answer. Now, with the number line, I always like to show my 0. And because we're involving 3, I want to show 3 and -3. And I scale my number line so that I can fit the numbers that I need. Then I think about that 2. Well, that 2 is right here. And it's not part of the answer because it doesn't verify for this expression. So therefore, I'm not going to be shading here in between the 3's. And that makes me remember how this works. We were seeing patterns last week. When you have a greater than, you end up shading on the outsides of the 2 dots that you put on your graph. When you have a less than, you shade in between them. That was a pattern we were noticing. Well, we need to remember that because it gives us a lot of shortcuts to be able to solve this without having to do all of this plugging. We don't always have time to do all this plugging. How about I try a number that I know is greater than 3, like 4? The absolute value of 4 is greater than 3. Then I apply my absolute value. The absolute value of 4 is equal to 4. And yes, 4 is greater than 3. This is a yes. It means that 4 is part of the answer. I want to be shading over here. So what I want to do, once I've done a bit of plugging, I get a feeling for where I'm going to be shading and where I'm not going to be shading, is I'm going to put circles on 3's. I'm looking at my symbol to decide, do I need to shade in those circles? And no, this is a greater than. It's not a greater than or equal to, so I'm not going to be shading in those circles. 4 verified. So we want to shade where 4 is, which means we're shading here. And we're applying that pattern that we had already noticed last week. We realized that the greater than sign means we're going to be shading on the outside. but outside of both dots. So over here and over there. Let's check that. If we try -4, which we know is over here, the absolute value of -4 plugged in, well, the absolute value of -4 is +4. And yes, +4 is greater than 3. So yes, that -4 is going to be part of my answer. And I am confirming that, yes, I'm going to be shading over here. And I use dots, but it can be an arrow. I show that it continues on. Because all these numbers, the negative direction, -5, -6, -1,000,000, they're all going to verify for this statement. So we're shading forever in that direction. We have our answer. But we can do this answer without all of this plugging. So I'm going to try to do another one, a similar one, but I'm going to do it without the plugging. I'm going to use what I understand about absolute value to help me to come up with an answer on the number line that I feel confident in. So, time for some erasing. My next one, absolute value of x. This time I have a less than or equal to symbol, and the number involved is 4. So I look ahead and I realize I'm going to want a number line. I want to show 0, I want to show -4, and I want to show 4. And I realize I'm going to need circles on there, on those two numbers, the -4 and the 4. Well, I'm starting to get my answer together quite quickly. I see the or equal to, and that makes me remember that I'm going to be shading in both of these circles because 4 and -4 are both values that will verify because of the or equal to. And then because it's a less than, the pattern tells me that means I'm going to be shading in here. So I shade in between them. And if I want, I can verify, just double check to make sure that I didn't mix it up and do it backwards, because that can happen, especially when we're beginners at this. And I can try a number like, say, -1. The absolute value of -1 less than or equal to 4. The absolute value of -1 is +1. And yes, +1 is less than or equal to 4. So -1 is a true answer for this situation. And it's shaded. It means I shaded in the right place. I can also double check with, say, +5. +5 should not verify because I'm not shading there. So I can write absolute value of 5 less than or equal to 4. The absolute value of 5 is 5. Is 5 less than or equal to 4? No, it is not. So it's not verifying. Therefore, it's not part of the answer. It makes sense. So we see that these patterns we can rely on, and they allow us to answer questions and to show our answer on the number line. We double check all of these things, especially remembering whether the or equal to is there or not. So let's do another one. So these are not especially challenging. We were doing these last week, but we're doing them a little faster now. I want to do another one, and another one that's got a little bit of a twist to it. And remember, when the teacher is erasing and drawing an example up, that is always a good time to take a sip of your water or to stretch your shoulders or do whatever exercise helps you to not become uncomfortable while you're sitting through a fascinating algebra lesson. That is good. Okay, next example. Absolute value of x greater than or equal to -1. Now, this is one that I hadn't done last time, putting a negative number over on this side. So it's slightly different, but that's the way we learn with math. When we're beginners at something, we try some of the easiest examples, and then we gradually experiment with some different things and see what happens. And then we learn how to handle all the different things that can happen in an algebra situation. I'm going to go right away and create my number line. I'm going to put a 0. I'm going to put -1 on it. And I'm going to also show 1 because I'm kind of getting in the habit of finding that whatever this number is, it's going to be useful on the number line. Okay, now, how am I going to do this though? I'm not going to do it just with logic. What I'm going to do is I'm going to write x greater than or equal to -1, but I'm also going to write x less than or equal to +1. This is what we usually do when we are showing our algebra to solve something like this. We take away the absolute value sign, but we have to sort of split it into two. And in one of them, we take away the absolute value symbol, but we keep this inequality symbol the way it is, and we keep this number the way it is. But the other one, we flip the symbol backwards and we change the sign of that number. This is what we have been doing with the other examples. It's just that it didn't really show because we were doing all this plugging to see what things look like, to figure out what our answer would be. But this works. Okay, x greater than or equal to -1. When I graph that on the number line, I need a solid circle on -1 filled in because it's greater than or equal to, and the numbers greater than or equal to -1 are going to go in this direction, and we're going to shade all the way over here because all of these numbers are greater than -1, except for -1, which is equal to -1. All of the answers are from here onwards forever. But we also have to graph this. X less than or equal to 1. Well, that's telling me to put a solid circle here. Okay, well, I kind of already knew that was part of the answer. It was shaded. And then shading to the left, well, it's already shaded here, but that means I have to shade here as well. And so what we've got is a situation where everything's shaded. You don't really need the circles because if I just put shading all the way across, we know that all of those numbers, including the -1 and 1, are part of the answer. So everything's part of the answer. Why? We can trust this. This works. But we can also think about why. When you think about it, the absolute value of anything always ends up being positive. And we're testing whether it's greater than this negative number. Well, all positive numbers are always greater than all negative numbers. So no matter what we plug in here, we're going to get an answer after we apply the absolute value that's positive and therefore has to be greater than or equal to -1. It has to be greater than -1. So that makes it make sense that everything should be shaded in the answer. So doing this special little thing by putting a negative number over there, we get to think about what we're doing, and it makes us feel confidence in what we're doing. This trick we're doing works. And this strange situation helps to verify it. I think I should do another example, though. I'm going to do one more very similar to the ones I did earlier before this one. And I'm going to show this split and this approach because this one being a little bit of an unusual situation, I don't want it to become confusing for anyone. How about looking for a symbol I haven't used yet? So the only one I can think of that I haven't used yet is less than. In today's lesson, that is. So I'm going to use a less than. I'm going to put the absolute value of x. I'm not going to put a negative number over here. And I want to choose a number that I haven't used yet. So I'll choose 2. And now we're going to do this splitting thing. But I'll get my number line ready. Put a 0. I'm going to show 2. I'm going to show -2. And then I'm going to do this split. The x without the absolute value bar is less than 2. And the x without the absolute value bar, I have to flip this symbol around, is greater than, and this becomes -2. So what we're doing is the same thing that we do when we plug. We figure out whether we're going to be shading on the outsides of the two numbers that have dots or on the insides. In this case, numbers greater than -2 are over here. The numbers less than 2 are over here. So we're going to be shading in between. But we already knew that because whenever we have a less than in these simple examples, we end up shading in between. So it makes sense. And this split makes sense. But it only works if you remember to reverse this symbol and reverse this sign. So you have to do that. It becomes part of the process that you have to do that. Okay. I'm just taking a look at the chat in case there's any messages coming in, and I'm looking at the time. And we're doing fine for time. So I'm finished with these very basic examples, and I finished with my first page. I will move on to my second page. I will do a bit of erasing. How about now, baby steps? We gradually add extra little details to our situations so that we gradually learn how to handle situations that have extra details in them. So this one is slightly larger than what we had been practicing with before. The absolute value of x plus 3. Okay, now we have a plus 3 inside the absolute value symbol with our x. And we have greater than 2. Okay, so I'm doing the split. I split this. I'm going to get my number line ready, though. Put 0. I'm going to put 2. I'm going to put -2. I may want to modify this. As we add extra stuff to our situations, we're going to have to modify how we show our answers in the graph. But it doesn't hurt to show a number line. It never hurts to show a 0 on a number line. I always don't really like looking at a number line unless I've put a 0 on it. And it really doesn't hurt to show these numbers, even if it turns out that we don't always need them. Okay, doing the split. I take this, I take away the absolute value, and I just have x plus 3. And I'm going to just write it with the greater than that I have and the 2 that I have. But I also take the x plus 3 and I write it with the less than and the negative 2. Same trick that we did in the previous example. And it always works. So we want to be able to depend on this as a technique. But we're not finished. Algebra. We've learned so many steps of algebra. I want my x isolated on one side of the equal sign, but this isn't an equal sign. But when it's inequalities, you still do the same thing. You do nearly all of the same steps in algebra when you have an inequality symbol that you do when you have an equal sign. So I want my x alone. How am I going to get it alone? I am repeating stuff that we've been going over for weeks. So I know the students already know this, but I'm going to, if I'm adding a 3 to the x, I will subtract a 3 from both sides. These cancel. X is now isolated. 2 minus 3 is -1. I have x greater than -1. Over here, I do the same thing. I'm going to subtract a 3 from both sides. Bit more chalk, please. These cancel. X is isolated. -2 minus 3 is -5. And here we see Doug was sort of telegraphing what was going to happen, because it turns out the numbers that we need to put circles on in our graph are not 2 and -2. Not this time. They're -1 and -5. So I need to, -1 and -5, so I need to make this a little longer. I'll put -5 about here. -1 is there. It's getting crowded, but it doesn't hurt. And I could add all the other numbers if I really wanted to. I just want to make it proportional. I don't want to put -5 right next to the -2. That wouldn't make very much sense. But the way I did it, considering I didn't use a ruler, it's not too bad. X greater than -1. So that means I'm putting a circle here. I'm not filling it in because it's just greater. It's not or equal to. And x less than -5. That means I'm putting a circle here. So the greater than -1 is over here. And it'll keep going. And the less than -5 is here. And it'll keep going. Okay. So I ended up, because there was a greater than sign, I ended up shading on the outsides of the two dots. And because it was greater than and not greater than or equal to, I have open circles. And neither of those two things is new. The only thing that's new is, instead of ending up using the -2 and the 2 for my dots, I ended up using -5 and -1. Should I be too surprised by that? Not really, when I think that this is what's different. This is what's changed. We have this +3 in here. So when I think 2 and 3, 5 is a number that pops into my head. When I think 2 and 3, and I think about subtraction, 1 is a number that pops into my head. So it's kind of interesting, but we can also verify. Let's see. What if I made a mistake? It's possible I made a mistake. I make mistakes on a pretty much a daily basis as a teacher when I'm doing math, I have to confess. But the good thing is students have a tendency to use the chat, or if they're in the room with you, they just say, "You made a mistake, sir," and then you realize you made a mistake and you're able to correct it quickly, because some of these students are really on the ball and they are understanding what you're teaching. So therefore, they'll realize when you made a mistake. I kind of like that. I like it when the whole class teaches the class instead of just this guy teaching the class. But I can also verify. So how do I verify? I try a number that I know won't verify and see if it doesn't verify. I try a number that I know should verify and I see if it does verify. I'm going to try 0. It's in the shaded section. So if I put 0 into my x position, I have 0 plus 3, but I have to do the absolute value. The absolute value of 0 plus 3 is going to be the absolute value of 3. And the absolute value of 3 is 3. And 3 is greater than 2, so it verifies. I'm putting a Y for yes. 0 verified, and I expected it to because it's in the shaded regions. I'll try -6 just for fun. I'll do it here. -6 plus 3 greater than 2. -6 plus 3 is -3. The absolute value of -3 is 3. Is 3 greater than 2? Yes, it is. I'm putting a Y. -6 also verifies. I'm starting to feel a lot of confidence that actually, no, I didn't make a mistake. And this is one of the things I love the most about math. Maybe more than an awful lot of other subjects we study, math puts you in a position where you can actually check whether you're correct yourself. So you don't have to wait for somebody else to come and correct your work and then find out the bad news the next day or a week later when you've forgotten what your answer was anyway. No, you can check it yourself while you're doing it and do things like verification, which allow you to say, okay, you know what? I know I'm right. It's nice to walk away from the question knowing you're right. I like that. Okay, I will also try something in here. I'll try -3 just to prove that it shouldn't verify because, hey, I didn't shade it, so it shouldn't verify. Plugging a -3 into this position, -3 plus 3 greater than 2. Make sure I copied it down correctly. But -3 plus 3 is 0. So I have the absolute value of 0 is greater than 2. Sorry, that's a little messy. And the absolute value of 0 is 0. Is 0 greater than 2? No, it's not. It didn't verify. And it shouldn't have because the number I plugged in was in the area that I didn't shade. I feel confident. This thing works. The thing with the split works even when we start throwing a few extra steps at the student. And that's why it's good to start with the basic ones, get used to the steps that work, and then start taking on the more challenging questions. Feel good about this. I hope the students do as well. And I see a bit of chat, so I'm going to take a quick look at it. Is there another way to know, or do we just have to test values for X? I think the other way to know is, to me, is the techniques we've been doing. That this technique where we rewrite this without the absolute value and the symbol the way it is, but we also split and do it, flipping the symbol and changing the sign of the number on the other side. Well, that's a way of knowing that what we should do. I don't know if that's a satisfying sounding an answer or if I really expressed it that well. What if the greater than sign has a line under it? If the greater than sign has a line under it right here, it means that we will fill in these two circles. So that is something we have to always check for. No line under it, open circles, yes line under it, closed circles. And that is about equal. So it's about what the numbers that where the circles are. It's not about all the other numbers with the shading, because all the other numbers in the shading are involving the greater than part, not the or equal to part. What happens if the right side is 0? Do we have -0 and +0? I'd like to try doing that one. I have a feeling that you could say we have -0 and +0 if you want, but -0 is still 0. So it's not going to change anything. I think it's worthwhile to do an example like that. What if there are X values on both sides of the equation? I could arrange an equation with X values on both sides that we could solve. And that would be a sort of a challenger question that we're not really doing yet in this lesson. I could also arrange X on both sides and create a situation where we wouldn't be able to solve it, but I really don't want to do that. But that happens in algebra, that you have multiple X values in an equality or in an inequality. That happens quite often, actually. Can you do a lot more examples? Well, that's a nice question to be asked, because I was kind of planning on doing a lot more examples, so I feel good about the examples I'm about to do. I realize that the students want them. I'm going to erase this one. I'll try to do a very similar one with the 0 on the other side of the equals, and we'll see what happens. I have a feeling it will solve rather quickly and simply without any big surprises, but I'm ready to be surprised. So how about X minus 2 with an absolute value? No, I'll put a plus because we hadn't really gotten into minuses yet. So I'll save that for another example. X plus 2, not too different from the last one. I'll put less than or equal to this time. And I'll put 0. And that is what one of the students asked about. So let's try this and see what happens. We do the split. We write X plus 2 less than or equal to 0. And we write X plus 2 greater than or equal to, well, I can write -0 if I want, but I'm pretty sure -0 is just 0. That whether you put a negative sign or a positive sign next to 0 won't matter. Quickly. There's another question I like, which I am going to talk about, but I'll just finish this first. Okay, so now I'm just going algebra to this. I have a 2 added to my X, so I'm going to subtract the 2 from both sides. So this 0 stopped being a 0 pretty quickly, actually. These 2's cancel, and X is therefore less than or equal to -2. I'm going to subtract 2 from both sides over here as well. I'm not going to write -0. I'll just write 0 because -0 is 0. and I'm subtracting a 2 from it. So, oh, interesting. I have a -2 on both of these. And these cancel. X greater than or equal to -2. And, oh, x greater than or equal to -2, but I also have x less than or equal to -2. And now I'm starting to see the student made me think, and I like that. I really feel like I'm a student right now. It's like I learned something, because that when you have to think about your answer, try and figure it out, but then you have that flash where you realize you have figured it out. Well, I guess that must be that moment when the learning really happened. And that moment when the learning really happened is extremely special to an educator. So basically, we have another situation where everything is a right answer. Everything is a correct answer. It's kind of similar to one I did earlier, where we showed solid circles, but we ended up shading everywhere, and we realized everything is a right answer. When it was greater than negative number, the absolute value of everything is going to be greater than every negative number. So we created another situation kind of like that. It's actually not very different. So I need -2. I need 0, and I'll show -2. Well, I didn't really have to show the 0. I felt like it. I need that -2 because both of these want it. It's or equal to for both this greater than or equal to and less than or equal to. So that's a solid circle. But I'm shading to the right of it. And I'm also shading to the left of it. And I'm putting these dots to show that it keeps going. So it happened again. Everything is a correct answer. But then we think about why. And we think, okay, the absolute value of something. No, you know what? I've got something back. I am really learning something. The student really has given me a good challenger question, because the absolute value of everything is positive. So I shouldn't have gotten everything as being the answer. I should have gotten nothing as being the answer. This is impossible. I shouldn't have even done all of this. I hope I haven't confused the students too much. I'll erase this answer first because I really don't like it now. What I'm going to do instead, and thank you for challenging me, student. What I'm going to do instead is say, well, it's impossible. The absolute value of everything is positive. So it's impossible for the absolute value of anything to be less than or equal to 0. So I guess I'll just write the word impossible. And I could try to draw a number line for it, but it would be a number line where you don't shade anything. And I find those confusing to look at, an empty number line. But the empty number line, I guess, would be my answer if I tried to draw a graph of this. It's impossible for the absolute value of something to be less than or equal to 0, because the absolute value of something is never negative. Well, that was an interesting example. Now I'm going to go back into my planned list of examples, because I was asked to also do lots of examples. And I need to get some more of them up there. And I'm going to take a quick look at the chat. And I'm going to answer that other question that the students mentioned. In fact, this is going to be a good question for me to do as my next example and answer that student's question at the same time. How about absolute value of x minus 4 less than or equal to 8? Okay, well, how do we do this? We do the split. We have x minus 4 less than or equal to 8, and we have x minus 4 greater than or equal to -8. Okay, I'm doing algebra. I'm not going to say everything, every step out loud like I usually do. I am going to just say I'm adding a 4 to both sides because I'm doing algebra, and that's what I do here. These cancel. X is isolated. 8 plus 4 is 12. Pretty big number. And it's an even number. Just happened to want to mention that. This one, I'm adding 4 to both sides again. These cancel. X is isolated. -8 plus 4 is -4. Not as big a number, but it's even again. The reason I'm pointing out it's even is because I'm now going to answer a question that was asked. I will repeat the question. Do the increments on the number line always have to be 1 unit? No. The increments you put on your number line are a choice you make depending on what type of values you have in your answer. So if all of my values were in the hundreds, well, I wouldn't want to be counting up 1, 2, 3, 4, 5. My number line would be miles long. These ones aren't in their hundreds, but 12 is a pretty big number. if I go up by ones, it's either going to be very crowded and they're too close together, or I have to draw way over there and it goes right off of the video camera angle. So what I'll do is I'll go up by twos. 2, 4, 6, 8, 10. I managed to fit 12 without going off the camera. And I'll show my 12. And then -2, -4. I'm going to show 12 and -4. I want to show them because they are values that matter in my answer. So I'll put the circles on them right now. I'll label that -4. I don't really have to label all of them, but I'll show this is where -12 is. And it looks kind of tidy, but I did not increment by ones. I incremented by twos because it was convenient to do so with this particular question. Less than or equal to 12. The or equal to means this is shaded. The less than means I'm shading in this direction. So I have a feeling I'm shading right up to this -4 dot, and then I'm stopping, except it's greater than or equal to -4. So yes, I'm shading to the right of the -4. I'm finished with the shading, but it was or equal to, so I need to fill in that circle. I have an answer. I have to be careful over here. So what I'm doing is I'm showing the little lines for 14 and 16, just to make it clear that it doesn't go, it didn't really fit on the camera very well, but it still makes it clear that it doesn't go on and on forever. I'm not putting the dot, dot, dot thing. Having the number with my circle on it so close to the end of the line I drew makes it a little hard to be sure what I mean. So I make the line a little longer just so that it's clear. That was fun. That's a good example. Next one. As I said, baby steps. We're changing little things. So we tried subtracting a number. We've now subtracted a number inside the absolute value. We had tried a couple where we added a number in there, and we see how it's different. And we're no longer saying, oh, there's an 8. I need to use the 8 and the -8. We're not really stuck in that strategy anymore because we've moved on from that to something where looking at that number and choosing to label my 8 and -8 is no longer a priority. But we can do other things in here. So let's try doing some other things in here. And that's what my next example is about. I am going to take a sip of my fizzy water, starting to get a bit of the chalky atmosphere, dry mouth. And I must say thank you to the students for asking such good questions. Okay, erase this. And I'll do my stretch while I'm at it, and I hope that you're doing your stretches too whenever you need them. I keep on saying it lately that when I stretch my shoulders like this, it feels like I'm stretching my brain. It feels like my brain is the muscle that's exercising right now. And as I'm always saying, it's cold outside. I'm wearing slippers, but I'm starting to think I don't really need them. I'm warming up because exercising your brain isn't very different from exercising your body. And if anyone ever asked, why does this teacher always wear sports jerseys when he's teaching? This is part of the reason. I burn energy when I'm teaching, so I get hot. And like an athlete, if I get hot and I'm wearing warm clothing or clothing that doesn't breathe, I'll start feeling overheated. It'll be uncomfortable. These clothes are designed to breathe because athletes exercise. And while they're exercising, their body generates heat. So it allows the extra heat to escape. Very handy. And it's interesting because when I come home, I very often immediately change into a regular t-shirt because I feel cold wearing the soccer jersey because it's letting all my body heat escape. But if I'm not exercising, I start to feel cold. Exercising the brain does the same thing. And so I'm feeling quite comfortable in this basement temperature right now. Interesting. Everything's interesting when you think about it. Everything is science when you think about it. And science is, this supercharged thing that's always all around us, he says. Okay, I am going to put another one down. How about if we have 3x minus 1 in the absolute value bars equals 11? Because we're starting to stretch our brains a little bit with this extra stuff, I'm going to do a few examples where I go back to the equal sign, which sort of simplifies part of what we're doing. We have a few less steps because a lot of the steps that we've been concerning ourselves with have to do with those inequality symbols. And this one, we don't have to really worry about that. We have equal signs. So I can tell you right now, in my number line and my answer, all I need is a couple of dots. I'm not going to be doing shading because it's the less thans and the greater thans that make the shading happen. But a number line with dots on it with no shading is still a perfectly good graph that shows an answer. Okay, let's try this. Split 3x minus 1 equals 11, 3x minus 1 equals, so I don't have to turn the symbol backwards, or if I wish, I could say turning an equals backwards doesn't change it, but I still have to put negative 11. So the process is slightly different. Now, let's do some algebra. This is just two algebraic equalities now. And we know how to handle those. We've been doing those for a while. So 3x minus 1 plus 1 equals 11 plus 1. I'm adding 1 to both sides. 3x equals 12. I divide both sides by 3. And x equals 4. Managed to write that neatly, even though it's getting a little low for me. 3x minus 1 plus 1 equals negative 11 plus 1. Okay, a bit more chalk, please. This piece of chalk is finished. I am going to take another one and load it up into this chalk holder thingy. Or maybe there's a name for these things. I never really noticed when I open the packages. Okay, these cancel. 3x equals negative 11 plus 10 is negative 11 plus 1 is negative 10. Be careful, Doug. See, I was sort of saying the answer before I was ready to. And now I have to divide both sides by 3. And then I realize I'm getting a fraction or a decimal on one side of my equal sign this time. But that's nothing to be afraid of. Those of us who are doing algebra are ready to handle algebra with fractions or decimals. We know our fractions and decimals. I could turn this into a decimal if I wish. I prefer it as a fraction, though. I'll write it negative 10/3. It feels like I don't really have to because it sort of shows negative 10/3 there. But there, I have a nice clear answer. I like this better because I don't have to round it. If I create a decimal, I would have to do rounding, and then my answer isn't quite as accurate. But I need circles on 4 and negative 10/3. How do I do that? Okay, 1, 2, 3, 4, 5. Show my 4, put a circle on it. It's a solid circle because it is or equal to, it's equals. And I don't have to shade, but I need to also put a circle for negative 10/3. Negative 10/3 is in between negative 3 and negative 4, right? Now that's really obvious when you have the decimal. I like rounding at least to the nearest hundredth with decimals like this. So negative 3.33, it's really clear it's between negative 3 and negative 4. But it's good if you are able to look at a fraction like negative 10/3 and still realize that's between negative 3 and negative 4. So negative 1, negative 2, negative 3, negative 4. I'll show both of those. But I don't want to circle on either of them. I want to circle at negative 10/3, which is going to be here-ish. But I have a great big circle, so it's a little hard to position it really nicely. And then what do I do? If I'm handing this in to someone, for someone else to see, I hope you can't hear it. Mocha is barking up a storm right now. Someone's at the door. If I'm putting a circle that's not on one of these increments, then how do people know for sure that the answer is negative 10/3 without having to look over here? And one thing I like to do sometimes is write negative 10/3. I don't want to create a number line 20 feet long showing all the fractions with 3 as a denominator in between. That would be too long. But I could, now people could see. That's negative 10/3. It may not be positioned perfectly because I didn't use a ruler, but I'm showing here that I have justification that my answer includes negative 10/3, and I'm doing my best to show it over here as well. So there's one of those what ifs. What do you do if you get an answer that's a fraction that's not a whole number? Okay. I see a question I don't understand, so I'm not going to answer it. What if there's a fraction inside the absolute value bars? I have an example here that I will get to eventually where I do that, so I will answer that. What if there are fractions and decimals in the same equation? What do I do? That's a question that's not restricted to only when we have absolute value, that's for sure. We have been doing algebra for weeks now, and it's quite possible to have a mixture of fractions and decimals. And what I prefer to do is convert all the fractions to decimals or convert all the decimals to fractions. But which one? Well, that's a matter of preference. A lot of students prefer decimals, but I prefer fractions. Like I was saying, you don't have to round with a fraction, so you know your answer is more accurate. But it is really a matter of preference. And if you really want to do a mixture of fractions and decimals, you can. If you have a good understanding of the numbers, that can be done, like 0.25 plus 1/2 is equal to either 0.75 or 3/4. I know that partly because I think about pizza a lot, but I also know that because I have familiarity, I have number sense, I have familiarity with numbers, whether they're decimals or fractions. And by practicing a lot, I realize that I'm able to handle that. But I'll confess something. When I said that example out loud, 0.25 plus 1/2, in my head, I kind of was thinking 0.25 is 1/4. And I just sort of did it in fractions in my head. I did what I said first, which is convert all the decimals to fractions, because that's my preference. Kind of a cool thing to do, kind of a cool question. If it's an equal sign, not a less than or a greater than, then it's just a dot on the number line, not an arrow. It is definitely just a dot. The arrows are more there to show that the shading continues on. But when you have an equal sign, you end up with dots and you don't have shading. So that means you won't need those arrows or the dot, dot, dot thing that I like to do instead of an arrow. Okay, I am going to move on to another example. And let's see what happens here. This is an interesting one. When I made up this question the other day, the first time I tried to answer it, I got it wrong. But then I tried to figure out why my answer didn't make sense, and it made me realize why my answer was wrong, and now I know I'm not going to get it wrong. But it makes me realize that there's something that the students need to know. So let me get the question onto the chalkboard wall once I've had my sip of fizzy water. And when something strange happens, you have to slow down. That's what you do. When you see, okay, there's sort of a curveball coming at me, there's something new and different in this example, slow down. That's my advice. So how about absolute value of x plus 6? Now, how I say it, I'm not saying the absolute value of x plus 6. I'm saying the absolute value of x plus 6. I'm trying to pace the words, put pauses so that people understand what I'm saying. But you understand it if you read it, equals 14. Okay. So the reason I got this wrong the first time I tried to do it was I immediately did the split. No. When you are dealing with absolute value, it's a very good idea. I would suggest it's important to have the absolute value part of your expression isolated on one side of the equals or the less than or the greater than, the equal sign or the inequality symbol. So I want to isolate this. And then I realized, well, of course, I know how to do this. I've been doing this for a while. The fact that there's an absolute value bars around my x doesn't change the fact that I see plus 6 there, and I know what to do when I have a plus 6 in algebra, and I don't want it there. I want to isolate this absolute value of x. If 6 is being added to it, I do the opposite. I subtract a 6 from both sides. So the thing, what I'm doing here is I'm simplifying this first before I try to do the split. These cancel. Absolute value of x is isolated. I wrote it kind of small. Equals 14 minus 6, which is 8. And what happened is now we're back to one of the more basic examples, like at the beginning of this lesson and a bunch of the examples from last week. But that's fine. We simplified to get there, and we know we can handle this. Now we're doing our split. X equals 8, or x equals negative 8. Can't turn the symbol around, or turn around equals is an equals, but the 8 becomes a negative 8 in one of these. And that means that my answer, I need the 8 and the negative 8 to show. I need circles on them. These are equal signs, so that means I'm filling them in. They are not less than or greater than, so I'm not shading, and I do not need dot, dot, dots or arrows. So I have my answer. It turned out to be an easy one, but we had to simplify first to get it to be that easy one. So we still had an extra step to do. We just did it at the beginning. Erase, erase, erase. Next one. Oh, here's one. And again, we keep on seeing something a little different. So here's something a little different. 5 times the absolute value of x equals 20. It's not really that different when you think about it. This is outside of my absolute value, and I want the absolute value isolated. So I'm going to do a simplification using algebra skills before I try to do the split. So I'm dividing both sides by 5. These cancel. This is now isolated. And 20 divided by 5 is 4. It turned into another easy one. With the split, we have x equals 4 and x equals -4. You know what? I'm not even going to draw a number line this time. We know what it's going to look like because it's such a simple one at the end. Okay, so we'll skip the number line that time. How about, this one's kind of cool that I have here. So let's do it. And I am going to also check the time. Ooh, okay, I don't have very much time left. But that's surprising me a little bit, mainly because I had so many good questions to answer. So there is nothing wrong with that. That made the lesson better. How about -2 times the absolute value of 3x equals -16? This is interesting because I start looking at it thinking, oh, it's going to be wrong. It can't work. It's impossible because how's the absolute value of anything equal to a negative number? But wait, we need to simplify and isolate our absolute value. We're learning a good process, a good procedure. I will divide both sides by -2. And now we realize what's coming. Once I divide both sides by -2, this is isolated. And this is going to give me a positive answer. It's giving me +8. Because a negative divided by a negative is a positive. So whoever made up this question sort of realized that that was going to happen and that it would be okay. Whoever that was. Yeah. Okay, now I do my split. 3x equals 8 and 3x equals -8. Divide both sides by 3. X equals 8/3. And divide both sides by 3. X equals -8/3. Sure, we can graph this on the number line, and maybe it's interesting enough because of the fact that there are fractions involved. There's my 0. 8/3 is between 2 and 3. So I'll show 1, 2, 3. 8/3 is going to be here. I can label the 1, the 2, and the 3, but I still feel it's not very clear. So instead, I'm going to label the dot 8/3. And then we can figure out that these are a 1 and 2 and a 3. -1, -2, -3, -8/3 is going to be here. I'll label that as well. That's kind of interesting. As for the verification, the verification is a little bit different when you don't have the inequalities. But it makes me feel like trying it. -2 times 3x is -16. I'm rewriting the question because this stuff creates clutter that makes it hard for me to see it. So, of course, with no shading, hardly anything should verify. Really, only -8/3 and 8/3 should verify. But I can try, say, 1. -2 times the absolute value of 3 times 1. -3 times 1 is equal to 3. The absolute value of 3 is 3. This is actually taking more steps than I expected. -6 equals -16. Well, we know that's not true, but we didn't expect it to be true because 1 isn't shaded and it doesn't have a solid circle on it, so it's not part of our answer. And if we try plugging 8/3 in, I guess I'll try to do it quickly. -2 times the absolute value of 3 times, we'll put 8/3 instead of x. This should verify. But 3 times 8/3, these 3's cancel. So we end up quickly with the absolute value of 8. And I'm feeling good about this. The absolute value of 8 is 8. A lot of people would want to skip this step. But I don't like skipping steps. I find things are clear if you don't skip steps. -2 times 8 is -16, which is equal to -16. I'm feeling pretty confident in this answer after all. That is cool, and I'm finished with this page. Okay. We had a bunch with equals. I have to do a couple, at least a couple if I have time, where we're back to doing some extra stuff, but we have the inequality symbols to prove that I'm not scared to deal with that. Algebra sure is fun. It's interesting how many different things we can do while still being in that field of algebra. It's a big field. It's a good thing it's so fun. Okay, absolute value of 2x minus 8 greater than 6. Everything here is inside the absolute value bar, so my absolute value is already isolated. So I don't have to do simplification first. I can go straight into my split. 2x minus 8 greater than 6, and 2x minus 8 less than negative 6. Slow down, be careful while doing these, because if you forget because you're going too fast, you're going to get all confused. 2x minus 8 plus 8 greater than 6 plus 8. These cancel. 2x greater than 14. 2x minus 8 plus 8 less than negative 6 plus 8. Oh boy, I am going through the truck really quickly. These cancel. 2x less than negative 6 plus 8 is positive 2. Divide both sides by 2. We are not flipping the symbol backwards. We're dividing both sides by a positive number. And x is greater than 7. Divide both sides by 2. And x is less than 1. Greater than 7 and less than 1. That's neat. So I'll put my 0 way over here so I can fit 1 and get 7 into a logical place. Greater than 7. Did that fit? Just barely. And less than 1. Huh. It's not or equal to, so I'm not filling in those circles. That was fun. Okay, I want to do another one, and there's something I want to make sure happens. I'm going to find an example where it happened. I thought I had examples where it happened. Yes, very next example. I didn't have to really stop and start studying this. If I had just moved on to the next example, I would have gotten to the one that I wanted to make sure happened. I was thinking something straight when I prepared this lesson plan, I guess. I'm just taking a quick look at chat. Oh, one of the students says, I'm getting the answer before you now. That's cool. All right. The next example, and possibly the last one. I was going to talk about functions, but that's not going to happen anymore in this lesson. Absolute value of negative 2x minus 2 greater than or equal to 4. Okay, I'm going to get a number line ready right away. Put a 0 on it. That's saying I kind of went off. I have to be careful not to go off the video rectangle. This absolute value is already isolated, so I can do my split right away. I'll do it, move way over here to give myself some room. Negative 2x minus 2 greater than or equal to 4, and negative 2x minus 2 less than or equal to negative 4. See, and here Doug's slowing down, being careful. Okay, I want to do some algebra steps that we've been doing for a while, so I'm adding a 2 to both sides. He's canceled. Negative 2x greater than or equal to 6. Let's do this one. Negative 2x minus 2. Add a 2 to both sides. Need more chalk. Less than or equal to negative 4 plus 2. Adding 2 to both sides. Negative 2x less than or equal to negative 4 plus 2 is negative 2. And the reason I didn't want to finish this one is because here's a point to slow down. We now are dividing both sides of an inequality by a negative number. There's that rule. These cancel. X is isolated. The greater than or equal to sign flips around to a less than or equal to sign. 6 divided by negative 2 is negative 3. We have x less than or equal to negative 3. So I can even start graphing my answer because I feel quite confident it's going to include this. But I have to do this one as well. Dividing both sides by a negative number, cancel, cancel, x isolated, the less than or equal to sign also flips backwards. So they both flip backwards. Is that always going to happen? Yes. In this situation, that's always going to happen. So you still end up with one less than and one greater than. They just kind of switch places. That's cool. -2 divided by -2 is +1. X greater than or equal to +1. Do the dots fit? No, they don't. So what I'm going to do is erase some of the shading, and then I'm going to put dots where they'll fit. And it's messy, but I did it. Okay. Now, I think I'm just going to pause, not try to do another example, and pause just to point out this thing about that rule, where when you divide both sides or multiply both sides of an inequality by a negative number, well, let's say the rule, you flip the symbols backwards. That just keeps on coming back. You learn it, and it's this detail, and you learn it, you're able to do it, you prove you understand it, but it's amazing how it just keeps on coming back. As you move on through your math career, you are going to be doing algebra a lot, because all these other topics of math that students move on to after this expect you to remember your algebra and make you use it all the time. It's why algebra is so important. And that little rule, if we forget it, we end up doing some higher level of math, and we're understanding, we're feeling confident, and then we get an answer wrong and we don't know why, and it's because we forgot that rule, and then we're all confused. Not good for our confidence. It's really good to slow down and remember this rule and make sure you use it quite often so that you won't forget it. I've met a lot of students who are higher than the algebra level where I teach who don't know that or don't remember that rule. And I feel that all of those students actually did learn it once, but they didn't practice it enough, and that's why they forgot it. Okay, so we are getting to the end of our time. I am going to thank you very much for being so supercharged and for being here. It was a delight as usual. I have some good light reading, or it might not be that light reading. We'll see, because maybe algebra for dogs is more complicated than the algebra that I normally read about, but I'm going to borrow this from Mocha tonight, and I am going to see if there are any surprises in here. I know one thing, I see an X, and it looks like an algebra style X on the cover, so that's good. But why a picture of a bone? Are there bones involved in the algebra when dogs do it? I wouldn't be surprised. Okay, so with that, I am going to say thank you once again. I will see you next time, and I am going to just look at the chat in case anything comes up while I wave bye, and I'm going to stop talking now. Bye.